It's working. All right, purple is the purple drive. So today it is, what is it, 3:12. All right, so here's our objective. What we really want to do today is we're going to be graphing. We're going to be graphing radical functions. Okay, so the whole term radical, I know I've been teaching forever, so back in the 90s it was like radical dude, and they didn't really know what they're talking about because they were just kids. But radicals are square roots, cube roots, and they call them radicals because they are those numbers that never end. Does that make sense? They're like pi. They're radical numbers. They're so radical they never end. They keep going on and on. They never repeat. They're radical, okay? Those are radical numbers. So if we're going to graph radical functions, we're going to be graphing square roots. That's a radical. We're going to be graphing cube roots, right? Those are radicals. So let's see how they look. So I can use my calculator. I really can. Thank you, girls. I'll borrow yours. I promise I'll give it back. Okay. So if I am going to graph these, I could go to on y equals. But first thing I say, okay, wait a minute. Let's check out our window, okay? So the window I want to use, I got my scatter plots on. Turn that off. It's going to mess me up, okay? Quit. Go to my window, and I suggest this window, -1 to 10. And I suggest this window, -1 to 4. Okay, now, before I even graph, let's use our brains. Let's use our brains. We're going to do square roots, right? Aren't we? -1. Right? I don't really have a whole lot of negatives in here because you can't. Can you take the square root of a negative number? Not unless you want to do I, and you're not going to graph I because I is an imaginary, right? So that's why my window is the way it is, because my graph will start at 0. It really will start at 0. So if I go to y equals, and I go to the square root of x, let's check it out. Let's see what it looks like. Graph. Looks like that, doesn't it? Now, it looks like it starts right up here, but let me fix this window a little bit more. -1 to 10. Scales by 1. There we go. -1 to 4. Let me graph it again. Who's been messing with my calculator? Scales by 1. Somebody's been messing with this calculator. Let's graph it. Now we go. Okay, so here's what I know. I could use the calculator, but you know what? I can do this faster. Honestly. Check it out. I can do this faster with my brain. So, you watching? 0. What's the square root of 0?
0.
Good. 1. What's the square root of 1? 1. Now I'm going to go all the way to 1, 2, 3, 4 because the square root of 4.
2.
Awesome. I could have done 2, but the square root of 2 is a 1.41, ugly decimal. It is a 1.41. I don't need that one. I could go to 3. What's the square root of 3? About 1.73, blah, blah, blah. I could do that one, but it's messy, right? So 4. What's the next one I want to go to? 9. 4, 5, 6, 7, 8. 9 squared root of 9 is 3, okay? Now, there are no negative square roots. You guys agree with that? So there's no values back on the x value, and there's no negative y values. So this is my graph. It just goes like that. It's really, in a sense, half a parabola, which makes sense, but it's a sideways half parabola, okay? So let's first of all, before I go too far, what's the domain of this? What's the domain? It's not negative, by the way. Hint, hint, hint. What's the domain? It is not negative, by the way. And x is greater than or equal to 0. Oops. X is greater than or equal to 0. And you're right, the range is y is greater than or equal to 0. Does that make sense, everybody? It can't be negatives. Domain and range has to be greater than or equal to 0, okay? All right, now, example 2. Well, I could graph it on my calculator. I really could, but I got to fix my window. Well, I got to go further down. I could make y to like a -5 and graph it, but I'm not even going to do that because I'm smart on that. Subtract 4. I mean, it looks like this. It looks like this, my graphics calculator. But I can do this without a calculator because I know I'm going to take what we call my parent function. This is my parent function. This is my parent function. and I'm going to take my parent function and just bring it down 4. So we're just going to take this graph and just bring it down 4. So let's do that. So I'm going to take it down 4, right? 1, 2, 3, 4. So I'm going to take my parent function and I'm just going to bring it down 4. So let's do the same thing from here. Okay? So if I go over 1 on my x value, square root of 1 is 1. If I go over 1, 2, 3, 4, square root of 4 is 2. See what I'm doing? We've done this before, right? I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. And there it is. Same graph, same exact graph, so I just pulled it down 4, right? Easy. What's my domain? What's my domain?
X is greater than negative
4? You're on the range. I like that. X is greater than or equal to 0. Does that make sense? 0. And the range, what's the range? Y is greater than or equal to negative 4. Good. Okay. Now, example 3. I could try it on the calculator. I really can. So if I put it on the calculator, I better check my window real quick just so you can see negative 4. And I'm going to go y equals, and I'm going to go clear that. I'm going to go square root of x plus 3 minus 2. Graph it. Well, that's kind of weird. What do you see? That's kind of weird, isn't it? It just stops in the middle of space, doesn't it? Well, that's because it's endpoint. It's not really a vertex. It has more like an endpoint. Its endpoint is at the coordinate negative 3, negative 2. Because remember, it's still, remember the silly little dance? This might wake me up. I need to wake up. Remember the silly little dance? Remember? So on the inside, it goes the opposite direction, right? And it makes sense. It's a great one to illustrate why it has to be negative 3. Because if it's negative 3, that would really put it at its lowest spot. Does that make sense? This is why it has to be the opposite. What value here would zero this out? What x value would zero it out? Negative 3. And that's why it's the opposite. That's why I keep saying it's the opposite. Because that value would zero it out. Okay, so then I'm going to go to my negative 3, negative 2, and let's just put it in. Okay, so same thing from here. From here. Over 1, square root of 1 is 1, right? Go back to the endpoint and go 1, 2, 3, 4. Square root of 4 is 2, right? You guys see what I'm doing? And then what's the next value? I'm going to go over how many from here? Let's go over 9, because the square root of 9 is 3. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. The square root of 9 is 3, okay? So these are the numbers I'm always using. I'm letting my x, in a sense, let my x equal 0, 1, 4, 9. I could do 16, but that's probably going to be off my paper, right? But these are always going to be my x values, so the same thing here. I went 1, square root of 1, 4, square root of 4, 9, square root of 9, right? So instead of using a calculator, this is actually much faster. How am I doing? Okay, I like that. Turn the page. Okay, this is easier than yesterday. You guys agree? A lot easier, okay? All right, how about a cube root? Okay, before I do a cube root, let me ask you a simple question, super simple question, okay? What is negative 2 times negative 2 times negative 2?
Oh, it's 1. Negative 8.
So the cube root of negative 8 is?
2.
Negative 2, okay? I'll do it again. Ready? Cole? Negative 3 times negative 3 times negative 3 is? Negative 27. So the cube root of negative 27 is? What's negative 1 times negative 1 times negative 1? So the cube root of negative 1 is? So we can have negatives. We can. Does that make sense? Absolutely. So let's take a look at this. So I can put this on my calculator. Okay. So my window says go from negative 10 to 10. And I'm going to go from negative 3 to 3. Okay, I'm changing my window. Okay, I'm going to go to y equals, clear that out, and I'm going to do cube root. So in my math button, I got a cube root, right? Cube root of x, right? Graph it. Okay, it looks like that. So you have negative values for cube roots, don't you? But we can do this very simply in our heads. We don't need the calculator. We really do. Because we know, first of all, we can go the cube root of 1. We can go the cube root of 8. Because all the rest in between are decimals. All the rest are in between are decimals. I can do the cube root of -1. And I can do the cube root of -8, and all the rest of the numbers are just decimal numbers. Okay, let's go for the ones that give us nice integer answers, and then we can graph it. So if I'm going to do that, then let's see what I get. All right, so start at 0, right? Cube root of 0. What times what times what makes 0?
0.
Good. Okay, cube root of 0 is 0. Now if I go over 1, cube root of 1 is 1, right? Now, I could do 2 ugly decimal. I could do 3 ugly decimal. I could do 4 ugly decimal, 5, 6, 7. But when I get to 8, what's the cube root of 8? 2. So we know that it's got to go from here to here, and there's a bunch of decimals in between, right? Okay, go back. -1. What's the cube root of -1?
-1.
Awesome. If I go 2 ugly decimal, 3, 4, 5, 6, 7 ugly decimal, 8. Cube root of -8. -2. And then what we have is all the ugly decimals in between, correct? All the irrational numbers. So all I'm going to do now is just connect my dots. And there it is. We've done this before. You guys remember doing this before?
Yeah.
So it's a nice little review, okay? Now, domain. What's domain and range of my cube root function? What's my domain and range? What's, first of all, domain of this graph? How wide is this graph? Yes. X equals all real numbers. And what's the range? Yeah, it's always going up. Slowly, right? But it's always forever going to go up, but very slowly. So, and it's always going to go down. It's always going down forever, but slowly. So y is also equal to all real numbers. Okay, now, what we have right here, everybody watching? Everybody watch. Right here, it's not a vertex. It's not a endpoint, but it's what we call an inflection point. And we've talked about that before. This is like an inflection point. So this is the point I want to move. I want to move the inflection point to -3, -5, right? Let's move the inflection point. Okay, so I'm just going to take my parent function here. I'm going to move it to -3, -5. 1, 2, 3, 4, 5. Okay. All I need to do now is take this parent function and redo it down here. So from here, let's just pretend we're at the origin, okay? Let's just pretend we're at the origin, okay? So you ready? If I go over 1, what's the cube root of 1?
1.
Easy. Go over 1, 2, 3, 4, 5, 6, 7, 8. Cube root of 8 is 2, right? Okay, now go back to your inflection point. If I go back 1, cube root of -1 is?
-1.
Awesome. 1, 2, 3, 4, 5, 6, 7, 8. Cube root of -8 is -2, and I'll just connect my dots. There it is. Now, domain and range are easy, aren't they? Domain and range. Domain is x equals all real numbers, forever wide, and y is also equal to all real numbers, forever up and down. Okay. Let's look at the journal. Okay. Let's look at the journal and see what the journal has to say. Okay.